Okay, part G. This is the final part of the final question of the final paper. It's hard, I'm not gonna lie. So, especially part 2. Part GI. Okay, it says z to the n minus 1 is equal to this. Express this as a product of linear factors over the set C, over the complex number set. Well, this is a linear factor, z minus 1. Now, we know 1 was a root of z to the n minus 1 equals 0. So the roots of z to the n minus 1 equals 0 are 1 omega squared all the way up to omega to the n minus 1. We know that from the previous parts. Now remember, guys, if you have a polynomial, if you have some polynomial or some, let's say f of x is equal to 0, and it has roots, let's say 2, 4, and 7, we can write the polynomial as, we can say f of x is equal to a times, so sum a here, although a is just going to be 1 here because our z is 1. It's going to equal a times, sorry, the coefficient of z is 1. It's going to equal a times x minus 2 times x minus 4 times x minus 7. We would have come across that in our sum and product of roots and when we studied polynomials. So I can write it like that. So if I knew the roots of this, which I do, I can write this z to the n minus 1. I can write it as z minus 1 times z minus omega times z minus omega squared times z minus omega to the n minus 1. But the question just says express this part as a product of linear factors. So I'm going to say therefore z to the n minus 1 plus z to the n minus 2 plus z plus 1. So this has to equal, because z to the n minus 1 equals this, z to the n minus 1 equals this, and there's our z minus 1 and our z minus 1. This has to equal, let me just change the color, this has to equal this. So I'm going to write this equals z minus omega times z minus omega squared. Let's put in another one. Z minus omega cubed z minus omega to the n minus 1. Okay, that's the first part. That's the easier part, believe it or not. Okay, next part. Hence, using the part GI and part F. So I've brought part F in here, using those results, or otherwise prove your result to part E, which was this. This was our result from part E, that P0 P1 times P0 P2 times P0 to the Pn minus 1 is equal to n. Okay, so we need to prove that equals n using this. So we know that z to the n minus 1 is equal to this. So I'm going to say this, I'm going to say this thing here, this z to the n minus 1 plus z to the n minus 2 plus plus z plus 1 is equal to this. Now, this is the tricky bit. I need to turn this part, I'm trying to prove this here. And I know that, well, P0, P1 is 1. and P0, P2 is 1 minus omega squared, and P0, P1 is 1 minus omega, P0, P2 is 1 minus omega squared, P0, P3 is 1 minus omega cubed, P0, P4 is 1 minus omega to the 4. How can I get, so essentially I need to get, because I'm trying to prove this thing here, so I need to get 1 minus omega, because that's P0, P1. We found out from previous parts that P0, P1 is 1 minus omega. So we need to say that times 1 minus omega squared times, because that's P0, P2, times 1 minus omega cubed, the magnitude of this, times dot 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 all the way to 1 minus omega to the n minus 1, magnitude of this. We have to show that all of that equals n. And we have to use this thing to show it. How can we do that? Well, can we see a connection between this and this? Well, yeah, this is 1 minus omega, 1 minus omega squared, 1 minus omega cubed. This is z minus omega, z minus omega squared, z minus omega cubed, up to z minus omega to the n minus 1. So this is very similar to this. So what we're going to do is, I'm actually going to copy and paste this here. So that's just the exact same thing. What I'm going to do is I'm going to say, now you may ask, how on earth did you know to do this? The first time I saw this, I mean, if I had to do this in an exam in 1 hour after doing all those other parts of the 2 questions, would I have got it right? That is definitely up for debate. I didn't do it in exam conditions, and I don't know, and honestly, maybe not, because this is really, really hard to see. So, I'm going to plug in my Mac. We are going to let z equal 1, because that will give me my 1 minus omega, my 1 minus omega squared, my 1 minus omega cubed. And if I let z equal 1 here, I'm going to get 1 plus 1 plus 1 plus 1. So I'm going to get 1 plus 1 plus 1 plus 1 plus dot 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 plus 1 equals, how many of these are there? Well, there's n of them, because there's all the way up to n minus 1 plus another one here. So there's n ones. So that actually equals n, which is nice, because that's what we're trying to prove. And if I let z equal 1 here, I'm going to get 1 minus omega, 1 minus omega times 1 minus omega squared times 1 minus omega cubed all the way to 1 minus omega to the n minus 1. Now, what we're going to do is we're going to get the magnitude of this, the magnitude of both of these. The magnitude of this is now n, and I can say that the magnitude of all of this is the same as the magnitude of 1 minus omega. I can get rid of that bracket now. 1 minus omega times the magnitude of 1 minus omega squared times the magnitude of 1 minus omega cubed times the magnitude of 1 minus omega to the n minus 1. So this is equal to n, and we know that that is equal to P0, P1, and we know that that is equal to P0, P2, and we know that that is equal to P0, P3, because we showed that here, all the way to P0, Pn n minus 1, which is what we're trying to prove. So we have proven our result to part E, which is right here. That's it, guys. Done. QED proved. I've proven what they asked me to show. Okay, guys, as I said, yeah, definitely, arguably that's the hardest part of the whole exam. But as I often say with these paper 3s, make sure you get like, there's at least half of the marks in this paper are accessible to everyone. The rest is to decide who gets the absolute top marks. But even, I mean, lots of people will get a 7 in HL maths without actually being able to do this final question. So don't worry if you couldn't do it. Okay, that's it, guys. I'll see you in your next past paper.